Hello, I'm ZUHDI from Grouping CP presentation. In this video, we will present about our group project, and this is our member. I'm gonna talk about introduction and objective. Okay, for introduction, our scope of project is developing one program in each commercial machine for facilitate users to use the machine, reviewing machine and operation analysis, and get correct parameter and calculation to fabricate forward piece. Okay, next is objective. Number one is to understanding the commercial machine and operation of lathe, mine and drill machine. Number two, to learn how to arrange the information in flowchart and procedure code. Number three, to learn how workpiece can be formed using commercial machine using C++ program. And number four, the last one, to learn how to develop a program relate to mechanical engineering in this project. Thank you. That's all from me.
Hi, my name is Syahfiq bin Mohd Shah. My metric number is CD200205. In this video, I will present about lathe machine, selected part design of lathe machine, type of operational process, formula of calculation, flowchart and pseudocode, and the coding. Okay, for lathe machine, the lathe machine used for shipping on material such as metal, wood, and plastic by causing the workpiece to hold and rotating by the lathe. The basic lathe usually using cylinder metal to develop it further to produce screw thread, tapered work, drill hole, kernel surface, and crankshaft. The typical lathe provide various rotating speed and the way to transfer cutting tools manually and automatically into the workpiece. There are 6 major parts of lathe machine, which is bed, the headstock assembly, the main spindle, the tailstock, the carriage, and overload safety device. The bed of a lathe machine is usually constructed of cast iron or hardened steel. It's hefty and durable enough to absorb all of the vibration that occur throughout the milling process. Large lathe machine may have beds that are made up for many pieces. The size of bed may also be dictated or influenced by the type of lathe machine. Next is the machine specification of lathe machine. The specification is as shown in this table. Okay, for the selected part design of lathe machine, this is the part design that has been chosen for the 3D selected part design and the 2D selected part design, the front view and the side view. Next is the type of material. The type of the material for lathe machine is wood, steel, aluminium, and stainless steel. After that, the energy consumption. Energy consumption, where energy is consumed in a machine tool, is an important step to reduce energy consumption. The majority of the energy consumed is attributable to supporting processes rather than material removal, deformation, or joining. It will be good to create an energy flow map to better understand the energy flow and consumption of machine tool. Opportunities for improvement, as well as energy related elements, can be found using this map. Following the creation of a map, models can be created to help estimate energy use and enable for machine tool optimization and for sustainable design. Okay, next is the flowchart and pseudocode. The pseudocodes for database: 1. Start. 2. Display all data. 3. Prompt user for database. If input 1, then display output 1. If input 2, display output 2. If input 3, display output 3. And if input 4, display output 4. Else, and then break. And number 4 is end. Okay, for the flowchart of database, firstly is start, and then display database, prompt input data, and if input is equal to 1, if yes, display output 1 and then end. If no, go to input equal to? If yes, display output 2 and n. If no, go to input is equal to 3. If yes, display output 3 and n. If no, go to input is equal to 4. If yes, display output 4 and n. If no, go to the end. End the process. And then the pseudocode for production. Number 1, start. Number 2, prompt user to select material. Number 3, choose between wood, steel, aluminum or stainless steel. Number 4, select the RPM for selected material. Choose between 200, 400, 600 or 800 and enter the diameter to cut the material. Number 6, if RPM is equal to 200. Number 7, continue process, facing, turning and finishing. Number 8, if RPM is equal to 400 or 600, continue process of facing and turning. And number 9, if RPM is equal to 800. Number 10, continue process facing. Number 11, calculate time process, calculate energy use. Number 12, display time taken. Number 13, display energy consumption. Number 14, break. And number 15, end the process. After that is the flowchart of the production. The flowchart of the production is as shown in this figure. Okay, for the coding, firstly, we call the library, which is studio.h and maths.h. After that, the database C code is void, and for array of database 1, the variable used is n, k, m, b and l. For array of database 2, the variable is g, f and v, and for the array of database 3, the variable is w. Okay, for the variable declaration, the variable is diameter loss rate, diameter workpiece, time, diameter, RPM, material, removal rate, minute, hours, energy and I. Okay, for database 1, the database 1 will shown in the screen, and then the material, wood, steel, aluminum and stainless steel also will be shown in the screen. Okay, for the loop is I is equal to 0, I less than 4 and I plus plus. Okay, it same goes to the database 2 and database 3. And after that, the user need to select the material above, which is wood, steel, aluminum and stainless steel. If the user choose material is equal to 0, which is wood, the user need to enter the RPM of the machine. And if user choose the RPM which is 200, the user need to enter the diameter to cut in mm. And then the time process and energy consumption will be shown in the screen. And it same goes to the RPM 400, 600 and 800. Also same for material 1, which is steel, material 2, which is aluminum, and material 3, which is stainless steel. If the user enter the value of RPM others than this for RPM, which is 200, 400 and 800, the invalid RPM enter will be displayed on the screen, and the user need to re-enter again the RPM. That's all for the coding. Okay, after that, the result of the coding. This is the snapshot of the output from the software. The output for the material used, which is wood, is like this. For the material use steel is like this, and for the material used aluminium, and the result of the material use of stainless steel. Okay, and that's all from me. Thank you.
Milling machine. Milling machine is a machine that performs a process in which the cutter rotates to remove the material from the workpiece, which is clamped on the working table of the machine that can move in three perpendicular directions. The material are cut by a rotating circular tool that has a number of cutting edges symmetrically arranged about its axis. Milling machine will only produce flat surface, but any shape that can be ground on the cutter will be reproduced on the work. There are two types of milling machine according to their operation configuration. The two main types of milling machine are vertical milling machine and horizontal milling machine. Machining specification. The milling machine that we choose to mill the workpiece is benchtop milling machine. The spindle speed is 2500 rpm. The advantage of vertical milling machine compared to horizontal milling machine is a vertical mill is cheaper than horizontal mill, which enable more workshop affordable. Next, a vertical milling machine is easier to use because the vertical mill provide better visibility to what is actually going on. Also, it is smaller and requiring less space. The specification of this model is shown below. The specification first is table dimension width. The value is 240 mm, and the second table dimension length 820 mm, and the third travel of XYZ axis is 6000 mm, 200 mm, and 250 mm. The power is 1.5 kilowatt. The spindle speed 100 rpm until 2500 rpm. The spindle feed rate 0.12, 0.18, and 0.25 mm per rev. And the spindle rotation angle is 45 degree. Motor output is 3 horsepower. Ram rotational angle 360 degree. The machine size 1040 mm times 770 mm times 1160 mm, and machine load is 405 kg. The operational steps. The operator is advised to accompany or help by an assistant to simplify the milling process. Do not wear loose outfits. Tie up the sleeve of shirt and wear goggles. Turning on the milling machine and let run for a while to make sure everything functions well and no electricity problem. The workpiece is put on the table of milling machine and adjust to suit the table. Insert all the values needed, for example working hours, spindle speed, feed range, workpiece information and others. Start the milling process. While the milling machine is operating, do not contact with the machine, especially touched by the revolving cutter. And then constantly clean the excess waste or chip during the milling process. For selected part design. For this project, we are going to design a program that enables a vertical milling machine to mill a I-beam. I-beam is a structural beam made of rolled steel with density 7870 kg over meter power. Different with H-beam, I-beam has a 4 curve on the end of 2 flanges. The size of raw material that we use is 200 mm times 200 mm times 550 mm. The design of workpiece is shown below. We can see from 3D view, raw material, product and side view. Take a look at the program we made utilizing code log to access the machine operated with a milling machine. We can acquire cutting speed, speed rate, removal rate, machining time, energy consumption, and we can also input the dimension of the workpiece and obtain analysis result using this program. By executing the software, I was able to examine the output. So in this situation, the operator must enter the machine operating hours as well as spindle speed, feed range, milling requirement, and dimension such as height, length, and width. The operator can get a variety of information from this program as a cost, production, and energy consumption.
Assalamualaikum and salam sejahtera everyone. My name is AZMAN bin SUNGEP and my metric number is CD200203. Now I want to presenting about our project specific to drill machines. Our group problem in drill machines. Our team assigned to estimate the part machining time, total energy consumption, total operation cost, solid waste generation, and productivity of the production per day. What our group project do in drill machine? In Department of Drill, Mega Metal Company produce the wheel spacer for their production. As referred to Aerosport Tuning 2019, wheel spacer are round discs that are installed between the rotor and wheels. The purpose of installing wheel spacer is to widen the offset of the wheel, which widen the vehicle track. The benefit of this wheel spacer is related to handling of the car even the tire size does not change. Wheel spacer is installed in front of the rotor and it can be thin as 3 mm or as thick as 23 mm. This company now produce the 5 mm thick wheel spacer. The figures below show the wheel spacer of 4 times 100 PCD. PCD is a pitch circle diameter. Okay, the specification of this wheel spacer that will be drilled in this company will be explained detailed in this figure and the table below. Okay, the diameter of the plate is 150 mm and the diameter of the 4-hole slug is 25 mm. The diameter of center hole is 50 mm. Thickness of the plate is 5 mm. Pitch circle diameter is 100 mm. It's called PCD, and the type of the material is aluminium. And the price market of the wheel spacer is 9 ringgit.
Next is the explanation of fabrications of the wheel spacer. So the figure shows the details of several steps on how the drill machine will operate the product. Firstly, provide the full circle plate with the thickness of the plate is 5 mm and diameter is 150 mm. As the circle have 4 quadrants, the first quadrant will be the first hole that will be drilled with 25 mm diameter, followed by circle that actually 100 mm diameter from center, which means the pitch circle diameter of the wheel spacer is 100 mm. Secondly, the second quadrant will be the second hole to be drilled with the same diameter, which is 25 mm. With the and then the third quadrant will be the third hole to be drilled. The last quadrant will be the fourth hole to be drilled also with a similar diameter. Lastly, the center hole will be drilled with 50 mm diameter. For flowchart of drilling machine, we begin the C program by entering the information of working hour, spindle speed used, and feed rate of revolution. After key in all the inputs, system will ask user to enter the thickness of workpiece. If the thickness is between 0 to 100 mm, system will proceed to the next step. Otherwise, the system will ask user to re-enter the value. Next, user have to enter value of radius of workpiece under the conditions radius is between 0 to 1600 mm. Same goes to radius. If it doesn't fit the condition, re-enter the value of radius is required. After that, user need to key in the number of holes and diameter for each hole to drill. Then it will show the outputs, which are solid waste generation and machining time. Next step, system will ask whether user wants to add any additional holes. If yes, it will go back to the number of holes and diameter of each holes to drill. If no, all the output will show up and C program ends.
Okay, now we reach to the simulation of the program for the problem that we use in drill machine. Okay, firstly, we need to insert the working hour for drill machine. In Mega Metal Company, the working hour is 8 hours per day, and enter the spindle speed that we use at the machine is 560. Okay, enter the feed per revolution. Okay, as referred to the Norseman drill and tools for diameter, for tools that diameter is 1 inch to 2 inch is 0.51 feet millimeter per revolution. Okay, maximum dimension allowed for the workpiece is 100 millimeter and radius is 1600 millimeter. Okay, insert the thickness of workpiece that we use is 5 millimeter for wheel spacer, and then enter the radius of workpiece is 75 millimeters, and then the diameter of workpiece will be 150 millimeter. Enter the number of holes required to drill. Okay, at the wheel spacer we require 5 holes that will be drilled. Insert the diameter of the first hole is 25, the second hole is 25 millimeters, the third hole 25 also, and then the fourth is 25, and the fifth is the center of the hole is bigger than the 4 lug holes, is about 50 millimeter. And then the program will ask, do you want to drill another hole? If you say yes, you will put the holes, the required holes that you want. Okay, now we will use no for this another drill. Okay, now if you know, the final result will be appear at the program. Okay, the final result is total part machine time is 0.088 minutes, and solid waste generation for the one pieces is 0.053 kg. Productivity per day is 5,483 pieces, and total energy consumption for X hour is 0.01 kilowatt per hour. Okay, operation cost per pieces is 1 ringgit 68. Okay, that's all from me. Thank you.
In conclusion, the main purposes of our project have been achieved. The project is very useful as it gives us a better understanding on how to develop a program related to the issue from real-world industry. However, there are some limitations that occur during completing the task, such as having difficulties of finding the details machines catalog with a complete data and information. This is because most of the company published only raw data and general information. They also published it through online platform and digital marketing, where it only focus more on the price of machine compared to the details of specification. Therefore, it is difficult to know deeper and have a better information regarding the machine.
And that's all for our group project presentation. Thank you.